Drilling fluids touch just about everything in the drilling process. We're here to deconstruct the drilling process and drilling fluid concepts to provide a deeper understanding of our industry. In each episode, we'll share information, talk to interesting people, and maybe share a few stories along the way. Welcome to the Flowline, a production of AES Drilling Fluids, brought to you by Matt Offenbacher and Justin Gauthier.
Hey everybody, welcome back to another episode of the Flowline. I'm here with, again, lovely co-host Matt Offenbacher. Matt, how's it going this sunny afternoon?
My goodness. I mean, it's going all right. We're actually teaching a mud school today, so I hope my voice can get us through all of this, but it's a lot of, well, you know how it is. It's just trying to bring the energy.
Right.
It's very exhausting. So,
Yeah,
I'll sleep well tonight. We'll put it that way.
I bet. No, and the good thing is over time we've, now have multiple people who can kind of fill some gaps for you, because I think for a while it was just you doing them all.
Yeah, that's kind of where we started out, and now I think even people who attend appreciate just different voices. You might say the same thing a little differently, and different experience, and so team lifting certainly helps. But there are a lot of they're pretty intense for us. I mean, we really try and do a good job and make it worth people's while for coming.
Yeah.
But it's also one of those, you still, even when you've done them a lot, you know how much work goes into it.
Yeah.
And you're kind of on. So yeah, I mean, and kudos to the rest of the guys who are working on them, because we don't have, I think it's actually a benefit. We don't have a training department per se.
Sure.
We do the training when we're asked.
Yeah.
And I'd found in other companies, sometimes the training department it's super helpful to just have people who that's all they do.
Right.
We don't have the bandwidth, we don't have the demand for that. But at the same time, like the latest and greatest that's going on the rigs and that sort of thing, we can work that into the material. And so it forces us to keep things relevant and stay fresh.
Yeah. Well, and that was actually funny you say that, because I was thinking of like what makes ours unique in that because we don't have a training department, it's because of the folks teaching it, yourself, Ricky, Will, you guys are also involved in the day-to-day knife fight, that we deal with on the account management side. And so you're like bringing relevant problems, challenges, trends, questions that are being asked by customers. You're then feeding into the material to help educate on what's really going on. Which is a big differentiator. I'm sure, again, I've never worked for a company with a large training department that's all they do, but I would imagine there's somewhat of like a framework and a template that remains the same over years and years. And the only reason they update it is maybe because they have a new instructor that then wants to like bring in something after X amount of years of doing the same thing. So, again, the feedback from customers that I know have attended is like, wow, like you really keep it relevant instead of it just being high theory. It's like, oh, like real world problems.
Yeah, I mean, we try. And the cool thing is, I mean, we've gotten some good feedback. So we get, I think we're now more where there's like little small knobs to turn, as opposed to like, oh, wow, we really should have done that differently. But yeah, so it's good. I learn a lot just by being there, because the types of questions people ask are informative to me, and maybe they lead to good podcast episodes eventually too,
Right. Well, after this one's done, I'm sure we'll have a few, but for today, Matt, we're going to talk, we're going to get back sort of in the technical weeds of things. Today's topic is going to be talking about high fluid loss squeezes, something that, we've developed, something that we, do day in and day out oftentimes with, especially with the rig spread we have. There's always at least one rig losing returns in the several that we obviously service. And so it can be somewhat complex and scary if you've never done it before, but if you have and you're comfortable and you've used a product that works and a procedure that works with a rig crew that's done it, then it can be very successful and save quite a bit of time and money. But on the contrary, it can also be a very challenging environment. So why don't we go ahead and talk about high fluid loss squeezes and see where that takes us.
I think it's a worthwhile topic. Like you said, it happens often enough, but it's one of those that it's not often enough where it kind of catches you off guard, but it's not ever out of the back of your mind.
Right.
And and the reason is simply a high fluid loss squeeze is when you're losing a lot of mud. I
Mhm.
mean, we typically have our plans for what we're going to do to deal with seepage losses or some partial losses. But once you get up to that 30, 40, 50 barrel an hour plus, where you're losing a lot of mud, and you start to worry about keeping the hole full, you've got to do something.
Okay.
And a high fluid loss squeeze is that's where this option comes in.
Gotcha. So, we've kind of so we got the environment, large seepage, partial losses, pretty high loss rate. What about the location? Is it typically out open hole, or could it be at the shoe, or a combination of of the two?
Traditionally, we'd say that at the shoe is where it's most likely, right? That's the weakest point. It's why we do our FIT there. It's why we, do those things. And sometimes we may pump a squeeze because we didn't get the FIT we were looking for, right? So we know our fracture gradient isn't what we hope it to be, and so we do a squeeze there just to beef it up. Um, the challenge is further out, you've got more open hole exposed, and so kind of locating this stuff and getting it in the right place, or even knowing that you're in the right place, unless you like catch a drill break and go on losses, and you're like, oh, we definitely cut through a fracture, and that's where all this is going.
Yeah.
Um, that may help you weigh whether you even want to try one. Is okay, how much open hole do I have exposed when I went on losses? And if it's further out, maybe there's a lot more risk of this not being very easy to close up.
Right. Well, let's assume we're sort of in the planning stage and the design work of something like this, because I think that's where it all starts. Obviously, is you've got to needing a good design, and then you go ahead and execute on it. But let's break down the design portion of a high fluid loss squeeze.
Yeah, so the difference here is I don't want this to seal up well. What I wanted to do is pack and seal within the opening wherever the fluid's being lost to, get squeezed out and sort of build a plug upon itself. And hopefully something that maybe even has some strength to it. So uh, a lot of this is you will take either a base fluid, diesel, like neat diesel, or neat water, and start adding materials to it, fibers, particles, diatomaceous earth, things that don't pack well together so that they will defluidize. And so you will put it in like a fluid loss cell. You may have a metal disc instead of an alloxite disc or a piece of paper with like a 5,000 micron opening. That's what a lot of people test to. I mean, you can test more, but you can see through the gap.
Right.
These are to lose that much, you got to have a pretty big opening. And so you'll put the fluid in, pressure up, and what you want it to do is you want it to lose a ton of fluid and then seal off. So you want basically your liquid phase is just a carrier for all these particles, and then you want it to separate out. So your design is finding particles that don't pack very well together, or don't seal very well, squeeze them out, and make sure that you form a plug. And then the question is, okay, does it have some compressive strength? Once it's all mashed together, does it stay together pretty well? Could it actually perform something where if I drill ahead, I've got something that's going to stay there and it's going to support the formation? And the other thing, in the design phase, it is worth considering, if you're going to have to weight it up a whole bunch when you pump it. Like risk of U-tubing, we'll get into procedure. That's a big thing. But the other part of it is barite is actually a relatively decent sealing agent, and so it improves the sealing efficiency of something you don't want to seal. And so I guess the thing I try and emphasize is almost every single one of these high fluid loss squeezes has a table in the back of add this much base fluid, this many sacks of product X, and if you need a mud weight, here's how much barite. And there's no viscosifiers, there's nothing like that. That's all it is.
Right.
And so they show you the table of what it takes to get a certain density, but that's just math.
Sure.
They don't tell you that, the more of this, more barite you add, the less likely this is going to work.
That's a good pro tip.
Yeah, so just I think keep that in the back of your mind as you consider that.
Is the material, or like say the product of a high fluid loss squeeze, it ranges in particle size, right? Like it's not typically just like one or two sort of like to say like a medium. Like it's got a wide ranging particle size, or can you speak on any of the?
I mean, you'd be surprised on what you can do to make something pack poorly. Like sometimes you want, some people go with the approach of I want them to all be the exact same particle size, because the idea with trying to form a filter cake or something is you have these different sizes. And so like when the big ones start to seal, little ones pack in between it.
Right.
But if you don't, if you have everything's about the same size, it can't do that, and so it just lets fluid flow through.
Got it.
A lot of them will have things like diatomaceous earth, which has, if you've seen it under a microscope, it's got all these pore spaces and everything. It's very difficult to seal. That's why we use it in a filter press. Is fluid will pass right through it, but it will pack off. Like it will let fluid leak through, but it will
right.
kind of limit your it won't seal fluid very well.
Got it.
So
Okay. So assuming we've got the design piece done, we've got a product that we're ready to deploy, and all of a sudden we get a call from the rig and, hey, we need that high fluid loss squeeze pill out here. Let's talk about the procedure, because that you may have a good product, but if it's not executed at the rig site properly, then it could be a big egg in your face. So the procedure is critical.
yes, and so we as the mud company, we're always going to offer up, here is the ideal procedure. And almost from there, it's a negotiation down. So I think, first things first, cleaning out your pit, flushing your lines, just like barite can affect the packing efficiency, so can anything that's in your pits. Immediately, sometimes we'll have to negotiate because someone will say, well, I just want to put this in the mud and pump it like a squeeze. I was like, well, that's not going to work nearly as well, but if you want to try it, okay. It's just all those mud particles are going to slow your leak off, and you're no longer going to have a high fluid loss squeeze. You're going to have lots of LCM.
Right.
And so, starting there and then, getting this stuff mixed. Normally, you need some time, especially when you're mixing 100 pounds per barrel or something in that neighborhood. Mixing probably about 100 barrel pill. Sometimes we'll mix 2 in case, follow up with a second one. But remember, this is just like base fluid and particles, so you got to keep the agitators on. It's not necessarily something that'll settle out of the pit or anything. You can see how these are mixed, and that's pretty basic. But yeah, you got to keep the agitators rolling. You got to keep this stuff going, and of course, do you already have it out there? Do you need it out there? Do you need to get some quickly from a warehouse? We don't. We normally kind of handle this all on the phone, and we have some pretty clear procedures that we provide.
Right.
Some other people who sell these things want to send a person out there, which I understand to some degree, but it's another cost, right? And you may have to wait for them. So anyways, you mix this stuff up per procedure, which is pretty straightforward. It's just it gets slower the more solids you have in the fluid. So make sure you got enough time to get all that stuff blended up. And then the other thing is, what are you going to pump this out of? And this goes back to, are you losing at the shoe or are you losing lower down hole? Because these things are designed to defluidize. I've heard plenty of people, it doesn't plug off a drill string. A more accurate answer is a proper high fluid loss drill squeeze hasn't plugged off a drill string yet, but it will. Because the types of flow pass through MWDs and all your expensive jewelry is about the size of a fracture that we are trying to seal. So if you don't have a bypass sub in there to completely divert away from the BHA, you should probably come out and go in open-ended. But we do recommend having at least a float in the string, because if you pump this stuff, you don't want it to YouTube.
Yeah.
And we've had people say, oh, I want to do it. I got a bit. Well, bit nozzles, similar fracture size. Like, you're taking a real risk there.
Sure.
And if it's designed to seal in a fracture, like, it doesn't know. It would be very difficult for me to confidently claim that there's not going to be a disaster where this stuff squeezes out inside the pipe and wreaks havoc. So I'm not going to recommend it. But in essence, if you have a pretty good idea of the loss zone, hopefully it's something near the shoe, or that's your best odds of success, unless you're absolutely confident. But get about 100 feet above it, because you want all of your stuff to fall down below you. So when you go to spot this stuff, you're going to pump, if you've got a 100 barrel pill, you'll probably pump 85 of it into the hole. And then, which if you think about a hole volume of an 8.5 inch hole or something like that, it's some healthy coverage. And then you want to leave a little bit inside the pipe, because that's going to be part of it you're going to squeeze out into the formation.
Right.
And then you kind of start this procedure. And there are other procedures. This is just a very rough outline of what we do. So you close the annular, you pump down the backside until you see some pressure. Hopefully you're building up that pressure because the stuff is defluidizing and it's starting to form a seal. You're starting to generate that plug. But once you see a couple hundred PSI, turn off the pumps and then let it sit. Let that stuff kind of set up, leak off a little more. And then you're going to do sort of these stages where you pump, 1 to 2 barrels a minute, really slow, squeezing. And then if you see a big spike in pressure increase, turn it off, let it set. And then do another kind of 2 barrel, really slow, let it set. And hopefully at this point, you are actually seeing, as you pump on it a little bit, what you're seeing is the pressure goes up and then bleeds off a little bit because that stuff is defluidizing.
Right.
And after you've done that, X number of stages, this is another thing that's difficult when you're talking to a customer is shut down for a few hours and let it set up.
Yeah.
So this is...
Oh, sorry, not to interrupt, but sometimes sort of your best ally is time.
Mhm.
When you're even just spotting a pill or, obviously in these squeezes like that, it's, yeah, because everyone wants to just hurry up and get through it and keep drilling. But, if you can have the patience and you get support from the operator, time can be on your side on stuff like this.
Yeah, I mean, I feel like it's the joke with like a stuck pipe spotting fluid where, they say let it soak for 24 hours. Like nobody's doing that. What they're going to do is they're going to tell you they want to pump this for the sake of pumping it, and then they're going to do whatever they're going to do, jar or whatever. And if it gets free, maybe you take credit for it. But, anyways, bleeding off your pressure, watching this, hopefully you got a good squeeze in there, and then you're going to circulate this stuff out and, see if you had anything left. So if there's some stuff in the well, it should come back at the shakers, but look for that. And so that kind of hesitation squeeze procedure is just push this stuff into the fractures. You may even want to apply enough pressure where you're sort of opening it up a little more and shoving this stuff in all the way to the tip and then letting it leak off, and it's sort of becoming part of the formation as this hardened plug. And hopefully from there, you've got a strengthened loss zone that is sealed off.
Yeah.
And it may be something where you go ahead and do another FIT, make sure that you've got the number you want to be able to drill the rest of it if you're near the shoe. But that's the general procedure that is involved just to getting these things placed.
Yeah. And I'll tell you, I've been on some that have worked really well and some that have kind of worked, but when these things work, it's super rewarding. I don't know what it is, but it's everyone is very pleased and relieved when you set one of these and, you go through the procedure, you go back into drill, you start increasing your pumps and you rotate and pump through it or wherever, depending on where you're at. But, yeah, it can be extremely rewarding for our mud company to set one of these things and it works. So, so let's say, obviously we've got the procedure, we've pumped it away. Things are good. What are some key considerations that we might want to keep in mind?
I think one of the things I can't emphasize enough, a commitment to the procedure. And that is the hard part because there are practical reasons to sort of make compromises on the procedure. But the more compromises you make, the more you didn't give it a chance to work. And then it goes back to why did you spent a lot of money on these things. You spent a lot of rig time.
Yeah.
So is it worth it to say something's too expensive when is it more expensive if it doesn't work? I guess that's the question.
Right.
The other part of that is just what are the odds for success? I mean, lost circulation is a sketchy game, right? Everyone will take credit for success and they'll have a reason for why it didn't work. But we've got to have product X. And it's like, well, I know exactly what's in it. It's nothing special. And, I'm glad it really worked for you, but insisting that because of that trade name, it's going to work, maybe not, but like the procedure matters just as much. And so when I hear, it didn't work, it's like, well, why didn't it work? It could be, maybe it wasn't designed properly, but a lot of times it wasn't pumped properly. And sometimes that was a choice and sometimes that was a limitation.
Sure.
You just didn't have a choice.
Yep.
And the other thing on land, I would say, is just when you're trying to think of big picture economics, a lot of times of high fluid loss squeeze is the last thing you do before you pump cement. And so in light of that, let's say I am at the intermediate shoe at 8 or 9,000 feet. Um, it may be between the costs of rig time and base oil and a lot of these other things. Um, check your economics. I mean, is it, if you're right there and you just cemented an interval, could you just squeeze the shoe with cement?
Right.
Further out, probably not. But if you're right there at the shoe, trip times are relatively short. We're already asking you to do similar things you would to do a cement job. Balance those things out and just make sure you've weighed all the options available.
Yeah. No, that's so true. At the end of the day, a lot of it comes down to economics. But again, like we always say, it's a tool in the toolbox. They do work when applied properly, and sometimes they don't. I mean, Mother Nature has its own sort of plans subsurface, but regardless, it's again they're extremely they can be extremely effective when applied properly, and with the right products, can definitely save some time and money. Matt, I don't have any other questions. Anything else for the audience before we get back to it?
No, I think we covered it.
Cool. Well, with that said, everyone, appreciate the support. As always, leave a review, subscribe, share this with someone, perhaps on a rig or, company rep or one of your customers. And be sure to follow us on LinkedIn. If you have questions, hit us up. You can reach us at the Flowline podcast at aesfluids.com. Be sure to check the YouTube page. Lots of great content being put out there. The website, of course, has all, great information on us as well, different products and systems. And geez, Matt, any other pages or things? I mean, if you're big on the Instagram, follow us there too.
Yeah. I mean, now I'd say like LinkedIn probably is like the central way to follow us, I think. But yeah, Insta, if you want to see when we're out and about at the charity events and other things. But yeah, and of course that's a two-way street. So please comment, follow, like, share, what have you. So
Yeah. Awesome, folks. Well, take care. Until next time. Cheers.
take care.
Thanks for listening. Please tune in next week for another exciting episode of the Flowline. And remember, may your returns always be full and your trips always smooth. Views expressed in this program belong to participants and not their employees. The program is for informational purposes only and cannot take the place of seeking professional advice. Copyright AES Drilling Fluids.